revealing secrets of the Earth and stars.
This will be the hottest place in the universe.
And blurring lines between minds and machines.
That is impressive.
Irish scientists have their fingers on the pulse.
This week on 10 Things to Know About, we're investigating the awesome power of the sun. Jonathan's in France, where the world's most complex engineering project is underway to replicate the sun here on Earth. Aoibhinn explores opportunities for the Irish solar energy sector. Meanwhile, I'm surrounded by all these firefighters to find out about Irish solar energy. No, really?
For centuries, mankind has sought to harness the awesome power of the sun, and recent developments in technology have made this more and more of a reality. It might surprise you to find out that Ireland is actually contributing greatly to the global solar energy sector. And I'm here today to speak with solar expert Prof Peter Gallagher to find out more about this incredible energy resource.
The sun is just one of the most amazing objects in the universe. If it wasn't for the sun, we wouldn't have life. It provides our light, and that gets the trees and the plants and the grass to grow, but it also gives us heat as well. It's absolutely intricate to the reason why we have life on this planet.
So we're here at Birr Castle and we have the Leviathan telescope behind us, and you're about to build another telescope here on the grounds.
Yeah, well, the Leviathan was my inspiration. I mean, why else would you come to Birr? It's kind of the heartland of Irish astronomy. In fact, it's probably the heartland of global astronomy. This was a telescope that was here from the 1840s right up until the 1920s. That was the biggest telescope in the world. Irish people had the biggest telescope in the world.
This beautiful old telescope was used to study the night sky. But Peter recently oversaw the installation of a new radio telescope called LOFAR that allows scientists to monitor weather conditions on the sun and help forecast its effects here on Earth.
The sun emits X-rays, ultraviolet, normal light, infrared light, microwave light and radio waves. And with the radio telescope, the thing is that you see the most active part of the solar atmosphere. You can see the whole atmosphere bubbling away and producing these flares that I'm so fascinated by.
While projects such as LOFAR are observing the sun, there's increasing interest in technologies that can harness the incredible energy emitted by our stellar neighbour.
The sun is producing, at the top of our atmosphere, about 1.3 kilowatts in every square metre. So if you look at the ground below us, that's 1 square metre. But the atmosphere then reflects about a third of that. Then the atmosphere absorbs another third of it. By the time it gets down to the ground, we're only seeing a couple of 100 watts per metre squared. That's like, a light bulb shining on every square metre. That's a lot of energy. And so what we need to do is develop detectors that can pick up that energy and convert it into electricity in an efficient manner. And that's what companies are now trying to do, to take that light, to take that 100 watts in every square metre and turn it into 100 watts of energy.
1.5 hours of sunlight on the Earth's surface is sufficient to meet the global energy requirements for a whole year. So how in Ireland can we reap the benefits of this incredible renewable resource? I'm here on the first solar energy farm on the island of Ireland to meet sustainable energy expert Brian Denvir. Brian, when I think of solar technology, I think of fancy rooftops in California, I think of panels out on the desert, and not necessarily a field in Ireland. Is it something that we can do in this country?
Absolutely, yes. I mean, it's not the sunniest day today, we've got a bit of cloud cover, but these solar panels will still be producing electricity because while they produce best when they're in direct sunlight, they still work when there's any kind of light. The technology that we have here is called solar PV, which is basically solar panels that produce electricity directly from sunlight. And that's the fastest growing electricity generating technology in the world in the last 5 years.
So could it be something that we see more solar farms like this one placed beside a wind farm that we actually see in the distance here?
Definitely, and that's a really good use of space. And as the costs of solar technology come down increasingly, we are going to see that more and more. So for instance, if you've got a factory where you have a high demand for electricity during the day, solar panels can really work. And the example we have here, this is feeding directly into the airport in Belfast. So it does make sense in certain applications already, and increasingly it'll become something that makes sense for homeowners to install. The solar market today is worth over $160 billion, and there are lots of Irish researchers and businesses who are already tapping into that. Some areas like material science, where Irish research is really at the forefront, developing new exotic materials, producing electricity, but also improving the materials we have.
Solar PV cells are made of wafers of semiconducting materials such as silicon. The greater the surface area of these silicon wafers, the more sunlight is trapped, and therefore the more electricity can be produced. Recent innovations to increase the surface area used a heated blowtorch-like device and plasma to etch into the wafers. But the process is expensive and complex, and an Irish company has come up with a revolutionary new technique which could radically improve the industry. Ed Duffy is CEO of 10ThingsS3 based in Tallaght.
Wafers are put into very large vacuum chambers, and complex plasmas are ignited, and that plasma does the texturing. And what we've done is we've simplified it, and we've taken it back to a point where we don't need vacuum chambers and we don't need the plasma. We have invented a whole new method here, and we've called it ADE, so atmospheric dry etching. The wafers are being loaded into the reactor in line as they move through, and they move into this reaction section here, and this is where all the magic happens, this is where the texturing happens. We brought it back to simplicities. We use a fluorine gas to do the etching, where you don't need the high energy plasma to activate the fluorine. That's the novelty in our invention. You don't need vacuum, and you can do it in an open reactor like we have. The machine we have here is a pilot scale machine. This particular system can run up to maybe 1,000 wafers per hour. And then the next systems, the production systems we're looking at developing now this year and through next year, would be multiple reactors, multiple lanes. They can do maybe 4 lanes, 4,000 wafers an hour, or 6 lanes, 6,000 wafers an hour. With the right automation and the right on-load automation, you can just run this 24/7.
10ThingsS3 sold their first prototype machine to the world-renowned Fraunhofer Institute for Solar Energy Systems in Germany, and they're collaborating with researchers there to evaluate and develop the technology for the mass market.
The exciting thing is that we've only scratched the surface of what this technology can do. With innovation, it's always improving, and there's still a long way to go.
Of course, innovation in technologies that capture the sun's energy is one thing, but for decades, one of the biggest challenges for renewables has been about how to store the energy for use when it's needed.
As we well know, in Ireland, the sun does not always shine when we want it to, but solar power can be part of our energy mix. We just need good storage and grid integration. And fortunately, in Ireland, we're actually quite good at it.
I'm meeting Cillian O'Connor from Solo Energy to find out about a new FlexiGrid solar energy storage system that's being installed in Ballyvolane Fire Station in Cork.
Battery storage is the solution to all our prayers when it comes to renewable energy.
Absolutely. I think it's widely accepted now that renewables are making their way onto the grid in a real way and slowly starting to replace fossil fuels as a significant source of generation on the grid. Traditionally, the problem with renewables is the intermittency of wind and sunshine, I guess. So we need things like storage to store that energy when the wind isn't blowing or the sun isn't shining to release it back into the homes and businesses. We've developed a software platform called FlexiGrid that controls and aggregates multiple battery storage systems across the grid. If you think of the electricity grid as a motorway, for example, during peak hours on the motorway, you could have 4 or 5 lanes of traffic backed up. Batteries can act as a relief road to ease some of that traffic congestion and help the grid operate more efficiently. Likewise, if there is a lot of renewable generation on a windy summer's night, for example, when there's hardly any demand on the grid.
It's bright till 10 o'clock, no lights are on.
Absolutely. What traditionally happens now is wind turbines will start shutting down, which is a complete waste of the energy that's there. But if you've got a smart network of batteries on the grid that can absorb all of that energy at that time for use the next morning, then that's the ideal scenario.
So it's like a master puppeteer of all the batteries, all the renewable energy sources and the grid, and says, you go there, you charge up, you turn off, and it's all managed
That's
in
exactly
the
it, all managed centrally in the cloud from Cork.
cloud. Wow, cool.
So this is the battery. It's a 10 kilowatt hour system, and that's storing the energy from the panels on the roof for the grid overnight.
So if this was fully charged, how long would 10 kilowatt hours last, or what would it power?
It would power a typical 4-bed home for a day. The loads in the fire station are obviously a lot larger than that. It wouldn't keep the fire station powered for a day, but it does contribute to a good bit of their demand.
They could make a good bit of tea.
A lot of tea, yeah, absolutely. Over here we've got the inverter and the control panel. Basically you can step through this here just to see what the panels are generating. Currently, how much is being stored in the battery, whether it's currently charging or discharging. This morning we were generating quite a lot. We were up to about 7 or 8 kilowatts. Clouds just came over there, so we're at about 1.6 kilowatts of generation from the panels.
That's something though.
Yeah.
So I can look forward to having something like this in my house in 10 years' time.
Yeah, absolutely. And not even 10 years, it's starting to happen now.
We've promoted a lot of projects to enhance energy efficiency here in Cork over the years, and within the brigade specifically, such as electric vehicles, PV arrays, solar arrays on some of our stations, and insulation measures, replacing light fittings with LED fittings, and now this is just another additional project.
Is it easy to use?
Very easy to use. It just sits there on the wall. We look at it every now and again, make sure there's a green light working on it. It was installed over a day and a half and commissioned. A very easy, quick, fast install, which is important in a brigade.
And you don't have to monitor it, someone else is monitoring?
No, it's monitored 24 hours a day, 7 days a week, 365 days a year. Since we've put the PV panel array on the roof, we're after reducing something like 4.5 tons of CO2 in emissions to the atmosphere, and that's an annual figure. So we're very pleased with that.
So not only are you saving lives, but you're also saving the environment.
Absolutely, in an environmentally friendly manner.
We're moving away from a world where a handful of large generators like coal and gas plants are generating all of the electricity and distributing that out to the homes and businesses, to a world where you've got tens of thousands of renewable generators on the grid, wind turbines, solar panels. So we need to move to a grid where it's much smarter, and you've got these clever platforms to manage it all.
The sight of whale strandings on beaches is one of the saddest, yet most puzzling sights in nature. And this year, scientists have proposed an explanation that is truly out of this world. And it all starts with the sun. Like the Earth, the sun has a magnetic field, but unlike the Earth, it has no solid surface. Instead, its surface is made of plasma, a superheated gas rotating faster at the equator than at the poles, pulling on the magnetic field lines and twisting them out of shape. Then, like the sudden release of a twisted elastic band, the magnetic field lines explosively realign during solar storms, driving vast amounts of charged particles into space where they can interact with the Earth's geomagnetic field. This field is not consistent throughout the planet, being stronger in some areas than others. By sensing these differences, it is believed that sperm whales navigate the sea using a geomagnetic map, in the same way that we navigate hills using contour lines on a map. But the arrival of charged particles can throw things out of shape, with magnetic mountains now suddenly moved by hundreds of miles. With their signposts now in the wrong places, it is believed that sperm whales can inadvertently venture into treacherous, shallow waters. While still a theory that must yet stand up to scrutiny, the long shadow of the sun could potentially reach even farther than we first thought. See you next time.
When we think of France, we might perhaps think of amazing food, sunny beaches and lush vineyards, and beautiful historical towns like this one in Aix. But in fact, you might be surprised to know that France has also been at the forefront of advances in nuclear physics for decades.
Just up the road from here, scientists are working on one of the largest and most exciting science experiments in human history. Inspired by the powerful reactions that happen in the center of our sun, it could be a game changer in our endless demand for global energy.
Nuclear fusion has been called the holy grail of energy, and I'm here to meet Bernard Bigot, the Director General of ITER, a project designed to prove the feasibility for this potentially limitless source of energy.
Fusion, which is a natural phenomenon. It is the sun, they are the stars. If it works in the nature, why the men are not able to master, to control and take advantage of it for his own purpose?
Can you tell us a little bit about the scale of ITER?
The scale is quite unique. Right now there is 35 different countries which are associated. And I also feel that the size of the facility itself is something which is amazing. So it's really a very challenging project.
The concept of ITER began as far back as 1985, and it projects that it will produce its first power by nuclear fusion in 2035. It's an epic project with a 180-hectare site and 3,000 people working on it.
Bernard, some people question the amount of money and time and effort that goes into this. What do you say to the skeptics?
What I said is very simple. The benefits are so large, it is worth to invest. Right now, the cost for this construction is around 20 billion of euro. Could you imagine that just in France, every year we are burning more than 25 billion of euro of oil and gas? Just in 1 year. If I succeed, it would be not for 1 year, it would be for millennium and even hundred of millennium.
The nuclear age began in earnest in the 1930s, when Irish scientist Ernest Walton and his British colleague John Cockcroft split the atom, for which they won the Nobel Prize. Nuclear power, as we know it today, still relies on this process of fission, or splitting atomic nuclei, which unfortunately also produces radioactive waste. However, the nuclear fusion concept here at ITER involves combining atomic nuclei rather than splitting them, and produces no long-lived, highly radioactive waste. One of the lead scientists is Deirdre Boylston from County Mayo.
I was in the right place at the right time because DCU at the time had the foresight to say, okay, there's a big effort happening in Europe, the Euratom program, which will govern all of the research done in nuclear fusion. And that basically gave them a means to get into the fusion energy experimental program. And we got a test bed that I could use for my PhD, and at the end brought me here to ITER.
Do you mind explaining what exactly is going on here? What is this enormous structure over there?
Okay, so this here is basically the tokamak complex, where we will have a machine that we call a tokamak. A tokamak is the vessel where we will recreate the sun. So we want to make a machine that can take the process of the sun, bring it down to Earth, and harness the energy that comes out of it. So fusion is basically taking two light nuclei of hydrogen on the sun, and you combine them together. And when you combine them together, you get helium and you get energy.
The tokamak is a large torus or donut-shaped vessel that is surrounded by a very strong superconducting magnet which creates plasma.
Everybody knows that you have solids, liquids and gases. But there's actually a fourth state of matter, and that is plasma. The sun is a massive ball of plasma. But how to make it all happen? 15 million degrees in the sun is not going to cut it for us here. We need 150 million degrees, okay?
This plasma is the perfect environment in which hydrogen atoms can be brought together to fuse into heavier helium atoms and release tremendous amounts of energy in the process.
This machine, this tokamak, is being built to give a net energy of 10 times what we put in. So if we put in 50 megawatts of power into this machine, we want to be able to extract 500.
So let me get this straight. You have this enormous magnet that surrounds these particles that are being heated to 150 million degrees. How does the whole thing not explode?
Well, the fusion reaction is very difficult to achieve. As soon as you make it too hot, too cold, not enough fuel, too much fuel, the whole thing stops. And there is no fear of an explosion. It just fizzles out.
Once the energy has been produced, it can be extracted and converted to electricity before being delivered to the grid in much the same way as regular fuels. Mike Walsh from Cork is head of the Diagnostics Division in ITER.
Right now, we're at the centre of the base of the tokamak. When this project is working, this will be the hottest place in the universe.
That is crazy to think about. Here is where the plasma will be spinning around above our heads.
Yes.
At 1,000 kilometers an hour.
Much faster.
Oh, really?
At a significant fraction of the speed of light.
Wow. It's kind of cool to think that I'm here at the center of an international experiment that could one day solve the global energy crisis.
Sure. You know, this project is working across the planet, from America to Japan to Korea to Russia. So all day long, 24/7, there's work going on in this project. We have to manage that in a coordinated and coherent way so that some people are not going too fast, some people are not going too slow, and they are communicating.
One of the comparisons you might make here is to the space race. And I guess one of the questions that comes up is it worth it, putting all of this money into it?
So just developing a project like this has huge numbers of spin-offs. For example, we use a lot of detectors, but the companies that develop them can then go on and use those detectors, for example, to have more sensitive detectors in hospitals, which then allow them to reduce the amount of X-rays that they use to make measurements. But of course, the experiment itself is absolutely crucial. It's a significant source of power that can last for a huge long time, and it allows us to be able to respond to the energy needs in the planet.
When you stand beside this machine and you think, I am a part of this, that will basically capture a star and we will put it into a machine and we will provide a power for future generations, giving clean, unlimited energy, inexhaustible fuels that we can use for this. It's inherently safe. I mean, imagine the benefits of that. So yes, for me, it is so exciting. I feel very proud to be part of this.
That's our 10 things to know about the sun. Next week, we're looking at the incredible advances at the forefront of genetics.